capital M. You can see here, FM hertz can be completely recovered from its samples if the signal is sampled at a rate slightly higher than Nyquist rate. The signal is sampled at a rate slightly higher than Nyquist rate. So let me repeat: a low pass signal band limited to FM hertz can be completely recovered from its samples at the receiver without any distortion if the signal is sampled at a rate slightly higher than the Nyquist rate. Okay. So first I have to understand what is Nyquist rate. What is this Nyquist rate? Right? Some of you might be telling the condition. I have asked you what is Nyquist rate, not the condition. Okay? Right. So Nyquist rate is minimum sampling rate. Okay? So minimum sampling rate is called Nyquist rate. And if you denote the sampling rate as Fs, S, okay? So Fs equal to Fm, right? And units is samples per second or hertz. So this is Nyquist rate, the minimum sampling rate. Okay. So now please understand this condition. The statement again. Low pass signal. So what's the low pass signal? How to describe low pass signal? We have two types. One is low pass signal, another one is a band pass signal. How you distinguish these two? Yes. So low pass signal, the spectrum of the signal is centered at 0. When the spectrum of the signal is centered at 0, now say for example, you see this one, right? And this is what is called a low pass signal. Okay. So examples of low pass signals are your message signals. Say voice signal, let's have a very good example, voice signal or speech signal. So low pass signal, band limited to FM hertz. Band limited means the highest frequency, okay, or the bandwidth, right? Both are same. So band limiting value or highest frequency or bandwidth, all these are same. So low pass signal, band limited to FM hertz. So that means this highest frequency is FM and this one is minus FM. So this is the bandwidth, okay, right? So different highest frequency and lowest frequency, again it is FM, okay, right? So that is what is the point here. Now, just now I have put a question: low pass signal and band pass signal. Now, what is band pass signal? The low pass signal spectrum is set at 0. Band pass signal, the spectrum is not set at 0, but at some other frequency. Okay, so that is what is called a band pass signal, right? So when this is the low pass signal, the spectrum of a band pass signal will look something like this. Okay, so set at some frequency, you see. Now, say for example, this is FC, right? Okay, so what I have done here, if you observe, we have translated the spectral range of this signal to a higher spectral range. So instead of getting set at 0, now this is set at some other frequency FC. Okay, so this we are calling as band pass signal. Now, when this is FM and this is at FC, now this point is here, so this becomes FC plus FM, that's correct. And this is minus FM, now we set at FC. So this is FC minus FM. So it's normally, considered as FC is far greater than FM. So, in simple terms, modulated signals are band pass signals, right? You can consider that. Example, message signals are all low pass signals. Okay, so that's what is our discussion, right? In the sampling theorem, a low pass signal, band limited to FM hertz, can be completely recovered from its samples if you sample the signal at a rate slightly higher than how much? The Nyquist rate. Okay, so the actual sampling rate, that's the point here. Okay, if you just go back into the video, right, and again observe the statement for sampling theorem. So the signal is sampled at a rate slightly higher than the Nyquist rate. So that means the actual sampling rate Fs should be greater than or equal to FM. Okay, units is samples per second or hertz. Okay, so we are going to prove all these things, right? So that means when fs is equal to 2fm or fs greater than 2fm, then you will be able to recover your message signal perfectly without any distortion. But when fs is less than 2fm, you will have distorted recovery of your message signal at the receiver. So that is what is the meaning of the statement of this sampling theorem. Now I am not still yet happy with this particular understanding of this fs greater than or equal to 2fm. So what we do is, before I prove that this is a condition to satisfy the sampling theorem, we will take a practical example. Okay, right? So let me run this one. Now, an example we will take. As I just told you, the low pass signal is a message signal, so we will take the example as a voice signal. Okay, right? So, what's the voice frequency range? I will end this lecture with this example, and in the next lecture we will see for the proofs, okay, right, of the sampling theorem, and then solve problems. So, what's the voice frequency range? Right? The audio frequency range is 20 Hz to 20 kilohertz. But whereas voice or speech, okay, frequency range, when you are speaking, the frequency range will be from 300 Hz to 3400 Hz or 3.4 kilohertz. That's the voice frequency range. Okay. So this is what is our low pass signal. Okay. Band limited to FM Hertz. So highest frequency is FM. Okay. Right. So that is what we are calling as bandwidth. So bandwidth of voice signal or speech signal. So F suffix capital M. Okay. Is 3.4 kilohertz. Okay. Highest frequency. So now, to sample the signal, the minimum sampling rate, that is the Nyquist rate, Fs equal to 2fm. So how much we get now? When fm is 3.4 kHz, 2fm is 6.8 kHz. And just now, we have seen in the statement that we sample the signal at a rate slightly higher than Nyquist rate. So, what is the actual sampling rate now? The actual sampling rate. So, actual sampling rate should be greater than 6.8, and normally that value that is used is 8 kilohertz, okay, to sample speech. So, where this is applied? That is the next question. You see, this example what I have told you is applied for our telephone communication. Okay. So, if you take a landline phone, for example, right, from your house, you are connected to a nearest telephone exchange by using the twisted pair cable, like the copper wire, okay. So, the transmission of signal from your house to the nearest telephone exchange is still analog, even up to this point, okay, till date. In the telephone exchange, you have this conversion from analog to digital using PCM. Okay. So between telephone exchanges, the signal that is transferred is digital. Okay. But from your house to the telephone exchange, the transmission is still analog. So when you are speaking in a phone, the highest frequency for your voice is 3.4 kHz. Now that signal with that band limiting value has reached the telephone exchange. Now in the telephone exchange, the PCM, is performing this A to D conversion. That first block, the sampler is sampling your signal at a rate of 8 kHz. So what actually does this mean? 8 kHz means, if you observe the discussion just now, this hertz also has the units, right, where Fs can also be termed in terms of samples per second. That means 8K samples per second also translates to how much? 8,000 samples per second. Okay. So now you see this interesting thing here. When you are speaking, when the signal reaches the telephone exchange, the sampler in the telephone exchange is sampling your speech at a rate of 8,000 samples per second. That means for every 1 second, 8,000 samples are taken from your speech. That is what is the point here. And this value of 8 kilohertz is used throughout the world. Wherever you go, right, any telephone you pick up and you speak, the telephone exchange sampler will sample your signal at 8,000 samples per second. That means every second 8,000 samples are taken. And normally, you talk for much longer time with your friends when you are using a telephone. Okay, for 1 second 8,000 samples are taken from my speech. Say for example, I have talked 20 minutes. You convert that into seconds, and you see how many number of samples are taken from your speech. Okay, right? So like this, 8,000 samples per second from your end to the destination, and from the other end, again 8,000 samples per second. Those samples are reconstructed, and you get back your electrical signal, and that is converted into sound, and that's what we are hearing. Okay. So this is a perfect example to understand, right, the sampling process. And please remember these values. So in the next lecture, we are going to discuss the proof of the sampling theorem. Why it should be fs greater than or equal to 2fm, and what happens when fs is less than 2fm. Okay, and all the next blocks, the quantization and coding also, we will put the discussions in the due course of time. Okay, so if you have any questions, you can always post in the comment section in the YouTube videos for this lecture, or you can also send me an email to mybhnuy@gmail.com. So I will reply within 24 hours. So please subscribe to this channel, share it widely with your friends, and we promise you that we'll deliver lectures to your satisfaction along with numerous problems for all subjects per gate. So until the next lecture, thank you very much.